Hi, my name is Nicholas Waba, and I am a junior pre-medical studies student at Jefferson University. And I'm going to be talking about an experiment we completed that determined the relative percentage of oxidized and reduced forms of myoglobin using UV VIS. I'm going to start by introducing what exactly myoglobin is. Myoglobin is a protein found in muscles that acts to bind oxygen. Myoglobin is specifically found in skeletal muscle and some cardiac muscle. It works by containing a heme group, which is a group that uses a iron as a cofactor. This iron can then bind oxygen. Due to this property, it's very high has a very high affinity for oxygen binding, which means that it's very easy to attract oxygen to the heme, but not very easy to release that oxygen, which makes it very effective at storing oxygen for long periods of time. Heme's function depends entirely on the polyporphyrin ring of its functional group, along with the iron located at the center of the polyporphyrin ring. This functional group acts to trap oxygen, and it's very effective at doing this because of that positive charge on the iron, as well as the fact that once the oxygen is binded, it actually forms a very stable molecule. This is for two reasons. One is that the iron becomes in a very planar position, also because the oxygen then can bind to histidine 64, which is on another part of the molecule, and this forms a very stable hydrogen bond, which makes it very hard for this heme to give up that oxygen. So the main objectives for this experiment was to first desalt a protein sample using gel filtration chromatography, and then we observed oxidized and reduced UV vis spectra of heme-based protein, which was collected using a different oxidizer and reducer, as well as just the basic sample that we had. And then we also calculated the relative percentages of oxidized and reduced forms of myoglobin in each sample. Next, I'm going to talk about the experiment that we completed. The first step of this whole experiment was to prepare the different cuvettes that we were going to need. The first one was labeled FCN, and this contained our crude lysate as well as potassium ferrocyanide. Potassium ferrocyanide is also known as a very, very good oxidizer of metal, which turns Fe2+ into Fe3+. Next, we had our SDT cuvette, and this contained sodium dithionite, which is known as a very good reducer, which effectively turns rusted metals into unrusted metals. And we labeled this SDT, and our third container was labeled SAV, and this was just our plain crude lysate. After we prepared all those samples, then we performed a gel filtration of the FCN sample. This effectively removed any possible the potassium from our sample, so we were just left with that oxidized myoglobin sample. And then after that, we performed UV vis on all three of those samples, and we could then calculate the exact concentrations from those absorbances at different wavelengths to understand what exactly that experimentation did to those samples. Here you can see the results of the experimentation. So the two things I want to point out here is that absorbance of 409 nanometers is where you'll typically find the oxidized version of myoglobin, and 417 nanometers is where you find the reduced myoglobin. So for this sample, you can see that FCN had a relatively high concentration of oxidized myoglobin, which is seen here, which is calculated, and the 417 nanometers, you can see it had a very low, and then SDT had a very high reduced form of myoglobin, which is seen here, and SAV had somewhat even of both. Overall, this experiment was a success as seen in the results, as you could see that the FCN was very effective at oxidizing and the SDT was effective at reducing. This also provided a lot of information on the percentage of oxidation in the original lysate. The results of this experiment actually found pretty sound evidence for uses of both FCN and SDT as oxidizers and reducers of myoglobin respectively. This experiment could also be used to perform on different oxidizers and reducers to affect their efficiency of action compared to FCN and SDT. And also, some things to note about the experiment was that there could be possible errors, but those could be worked out with a multitude of trials.